Now. Start right now. There we go. All right. Hey, tonight's reading is on predicting earthquakes. I'm going to read two sections for you. This is 5.12, and we'll do 5.13, and we'll start to get ready for our test that we're going to have on Monday. It's only going to cover what we've done in class. And anyway, you should be able to refer back to the sections that we've read. The majority of them have been very short, but tomorrow I'll give you more specifics to help you better prepare for the test on Monday. Here we go. Predicting earthquakes. What if you could predict an earthquake? What would make a good prediction? Knowing where, when, and the magnitude of the quake would make it possible for people to evacuate. If you were right, you would be famous. But if you were wrong, many people would be angry with you. Earthquake prediction. Scientists are a long way from being able to predict earthquakes. A good prediction must be detailed and accurate. Where will the earthquake occur? When will it occur? What will be its approximate magnitude? With a good prediction, authorities could get people to evacuate. But if the prediction were wrong, a lot of money would be lost as people closed businesses and skipped work. Plus, people would be unlikely to believe the authorities the next time. Kind of like that cry wolf syndrome. You hear it so much, then you begin to ignore it. Predicting where. Where an earthquake will occur is the easiest feature to predict. How would you predict this? Scientists know that earthquakes take place at plate boundaries. They tend to happen where they've happened before. You can see right here, most earthquakes occur here in the United States. We have several that are right here along the Mississippi River. We've already talked about this before. Especially in class. And then right here, remember I referred to Charleston, South Carolina? It has more natural disasters of different kinds affecting it. You've got earthquakes, tornadoes, and hurricanes all having an impact right there. Then, of course, look at Alaska. There's a lot of earthquake activity because it's at the top part of the Ring of Fire. All right, let's keep going. Fault segments behave consistently. A segment with a frequent small earthquake will likely continue to have frequent small earthquakes. A fault segment with an infrequent huge earthquakes will likely have infrequent huge earthquakes. The image below shows the probabilities of earthquakes striking along various faults in the San Francisco area. The time frame is between 2003, when the work was done, and 2032. So that's a wide range in years. It's about 21 years. 19 years. Predicting when. When an earthquake will occur is much more difficult to predict. Stress on a fault builds up at the same rate over time. So earthquakes should occur at a regular interval. But so far, scientists cannot predict when earthquakes will occur even within a few years. Around Parkfield, California, an earthquake of magnitude 6.0 or higher occurs about every 22 years. So seismologists predicted that one would strike in 1993. But that quake came really in 2004. 11 years later. You can see right here they were using this to help them predict when it was going to occur. Earthquake signs. There are some signs that a large earthquake is coming. There may be small quakes called foreshocks. These can occur a few seconds to a few weeks before a major quake. Unfortunately, foreshocks are not very useful for predicting large earthquakes. Many quakes do not have foreshocks. Also, small earthquakes are not necessarily followed by large earthquakes. There are other possible signs before an earthquake. The ground may tilt. The ground tilting is caused by a buildup of stress in the rocks. This may happen before a large earthquake, but it doesn't always. Water levels in wells may fluctuate. This is because water may move into or out of fractures before an earthquake. This is also an uncertain way to predict an earthquake. The difference in arrival times of P waves and S waves may decrease just before an earthquake occurs. Folklore tells us that animals behaving strangely just before an earthquake. Most people tell stories of these behaviors after the earthquake. Chinese scientists have actively studied the behavior of animals before earthquakes to see if there was a connection. So far, there's nothing concrete in these studies. Actions can reduce the damage once an earthquake has started. Seismometers can detect P waves for a few seconds before more damaging S waves and surface waves arrive. In this time, computers can shut down gas mains and electrical transmission lines. They can initiate protective measures in chemical plants, nuclear power plants, mass transit systems, airports, and roadways. Just a few seconds can be tremendously valuable. Now let's take a look at this vocabulary. Foreshock. These are those small earthquakes that occur before a big one. In summary, a good prediction must indicate when and where an earthquake will take place. Fault segments behave the same way, usually over time. Signs that earthquakes may occur include foreshocks, ground tilting, water levels in wells being at different levels, and the relative arrival times of P and S waves. Now, when you pull this up in your e-text, go ahead and read what it says, listen to the video. It's about 11 minutes long. You go ahead and do that. And there we have it. Let's press on to the next section. All right, so we're going to go to 5.13, talking about tsunamis. This is great because we just saw that video today of that river rushing backwards and flooding that town. That was just catastrophic. I just couldn't believe it. All right. 21st century tsunami. Right here, this is a picture of what it was like when the Indonesian tsunami hit. Why should you pay attention in school? Tilly Smith, age 11, after her family were walking along the beach in Phuket, Thailand, on December 26, 2004, Tilly noticed that the sea was bubbling. She thought this was like a video she'd seen in geography class 2 weeks earlier. The English schoolgirl insisted to her parents that a tsunami was coming. Her warning saved approximately 100 tourists and others who were on that beach. Tsunami. Earthquakes can cause tsunamis. These deadly ocean waves may result, from any shock to the ocean water. A shock could be a meteorite impact, a landslide, or a nuclear explosion, but most come from large underwater earthquakes. An underwater earthquake creates a tsunami this way. The movement of the crust displaces the water. The displacement forms a set of waves. The waves travel at jet speed through the ocean. Since the waves have low amplitudes and very long wavelengths, they are unnoticed in deep water. As the waves reach the shore, they compress. They are also pushed upward by the shore. For these reasons, tsunamis can grow to enormous wave heights. Tsunami waves can cause tremendous destruction and loss of life like we saw in the video today. Fortunately, few undersea earthquakes generate tsunamis. The Boxing Day tsunami. This is what we saw in class, 2004. The Boxing Day tsunami struck on December 26, 2004. Oh, excuse me, maybe it wasn't. Let's just keep reading. The tsunami was caused by one of the largest earthquakes ever recorded. The Indian Ocean earthquake registered a magnitude 9.1. The quake struck near Sumatra, Indonesia, where the Indian plate is subducting beneath the Burma plate. It released about 550 million times the energy of an atomic bomb dropped on Hiroshima. Several tsunami waves were created. The waves went around the Indian Ocean and struck 8 countries. About 230,000 people died. More than 1.2 million people lost their homes. Many more lost their way of making a living. Fishermen lost their boats. Business people lost their restaurants and shops. Many marine animals washed on shore, including dolphins, turtles, and sharks. The Japanese tsunami of 2011. The Japanese received a 1-2 punch on March 2011. The 2011 Tohoku earthquake offshore was a magnitude 9.0, and damage from the quake was extensive. The earthquake generated massive tsunami waves, which hit the island nation. Waves in some regions topped 9 meters, or 27 feet. The tsunami did much more damage than the massive earthquake. In the photo Sendai below, black smoke is coming from an oil refinery. The refinery is set on fire due to the earthquake. The tsunami prevented efforts to extinguish the fire for several days. Worst of all was the damage done to the nuclear power plants along the northeastern coast. 11 reactors were shut down. Power and backup power were lost to the Fukushima plant. This led to equipment failures, meltdowns, and the release of radioactive materials. Cleanup of the disabled plants will go on for many years. Most of the Indian Ocean tragedy could have been avoided if a warning system had been in place. As of June 2006, the Indian Ocean now has a warning system. Communities around the Pacific have had a tsunami warning system since 1948. As in Japan, warning systems aren't always helpful. People in communities very close to the earthquake do not have enough time to move out of the area. Further away from the quake, evacuation of low-lying areas saves lives. Here we see the definition for tsunami. That'd be probably a good thing to remember. And then we have these things to remember from our reading right now. You can pause the videotape and take a look. Now, this National Geographic video is obviously temporarily unavailable, so we won't watch that. And that's it. You have a good night. I will see you tomorrow. We will answer some questions based on the reading tonight. See ya.